I have tech issues.
Oh no, what's happened?
Uh, OBS was misbehaving. My game's not running right.
What brain is there? I'm not going to shout out because I don't know if he's it, so.
Exactly.
What?
Okay. Look good. Let's just get started here. Love you.
What is it?
Yes, I am. Hi, hi. I am so sorry. I have tech issues this morning. Good morning, the brain of BFW and Ronnie. Nice to see you. How you doing? Tech issues left, right, and center. It's fine. It's fine. Copy thusly. Change it quickly on the YouTube. Ding, ding. This is yes. Well, it's not exactly in that playlist, but it's fine. We'll do it like so, and then we will see. Also, I forgot another thing. I'm so not. I live on tech issues. It's the fact that I've even changed my entire system to non-Windows. We're now completely on Linux, so my entire desktop is on Linux as well. And you know, some games are better behaved than others. Let me go like so, okay, and I will try and start the game and see what happens. If the game starts. Yes, yes, it does. There we go. So this is called The Miner Was Replaced, and it's essentially a programming game, I want to say almost. What I would like to do though is we are going to go and throw away this here Oh, what's the news? New game, Strim. Let's start. So, and essentially we have our sort of help window and we have our actual program window. So this is where actual programs are going to be typed and are running. And so it says here first program, and the first program is essentially just harvest and do a flip or something. Like we can just copy this if we wanted, or we can just type it out. Oop, if I can type right. Oh, nice. We'll do harvest and then we'll do flip. Do a flip. So that's the two functions we're calling here, and let's just run this. Whee! It harvests and then it stops. Like we need to do this, I think 5 times. I think that's how much it is. Yes, it's 5 star for unlocking the loops. Now, what we can do, make this a bit easier. While true, basically an infinite loop, just keep going until forever. We don't have if yet, so just say harvest, right? Nope, don't need that, and go. Now so you see it literally just repeating that instruction over and over again. Let's go and grab something like, I don't know, 20 hay. And let's have a look at the unlocks. So we need 20 to get more speed. I finally put the trigger on what? So more speed. Now we can check. So what we can do here is we can say while true, check the field underneath you to say if can harvest. All right, nice, good, getting there. If can harvest, we harvest. And I think else do a flip. Like something like this. Okay, let me check actually what's required for the next unlock. We need 300 hay and 350, so maybe we are just not going to do this at all. Right, this is all just taking cycles that we could save and be faster. Yes. Cool. Yeah, well, reload that. Yeah, I was going to say, even if they refuse, there should be a way to still force the issue somehow. But no, that's good to hear.
We're not doing this.
Button, there we go. We could expand out to make this faster, actually. Let's do that. So stop. If can harvest, and then after you've harvested, basically move north. And the way that works, basically, once it hits the edge here, the top farm tile, it will just wrap around and start at the bottom again. So we don't need to do fancy things there. We can just literally hit go. Nice. Stop, Patch. Go lie down. Come here.
I've got him.
Not doing this. 150. Yeah, we're getting more hay. So let's see what else we can do here. We could learn to plant bushes. I think that would be usable. Or we just wait until the other 101 straw or grass are in here and then we can make it faster. Yeah, maybe we'll do that. And then we will, fuck it, we'll do this right now. Stop. So we probably want to clear the farm first before we do any sort of planting, and then if we can harvest, and then once we harvested, we will plant entities.bush. We all need to have a little bush apparently. And then you move north, and you keep going. And you can see it now going over and just sort of skipping the tiles since they're not harvestable every single tick. And you can see them growing there. Okay, I feel like I want to. Do we have? I want to quickly see. Do we have? Excuse me. Do we have ways to detect where we are at the moment? No, I think that would be in here. Moving. No, not necessarily. There is something where you can basically see. Is it you? Ah, there's a census. Okay, so we need. Oh, well, we can do this. And then that would lead us to allowing detection where we are, right? This XZ thing, XY. Oh, okay, have a good sleep. Yeah, we'll just keep move north. We'll need more grass, so for now we're gonna plant more grass. And what do I need for the next unlock? Just 100 straw. Perfect. Okay, because my thought is what we want to maybe do is plant grass maybe just on one of them and the other two get bush, but we can do sort of a detection of where we are. Come on, 13 left, 12, 11, 10. Okay, so we can now say stop for a second. Then please give me census. Okay. I think I'm just gonna say here if position Y, because we're moving up at the moment. If it's 1, we'll plant grass, right? And in any other case, we will plant a bush. How's that? Let's try that. Oh. This is the function object itself. All right, okay, well, we are meant to call this as a function. Whoops. And now we're seeing exactly that. Grass being planted in the middle and the outside to have bush. Good. Right, what's the next unlock that we can do? More speed would be almost doable. Yeah, let's do more speed. Right, can see it going faster now. And then we will want to expand, I think, out again, so now we need to change this. Let's get rid of all of this. We will want to do, I think, a for loop, right? And y equals 0, y equals get world size. Tells us basically how big our x and y's are. And y plus plus. Right. Do that same again for the x. So for going along. Oh, apologize. If can harvest harvest if we can harvest, we harvest. We also do a planting here. So what I'm thinking is if y equals 1, plant entities dot grass, and the other two rows will have bush. Something like that. And then we move right, so move east. Right, that's on the inner loop. And then we move north. Once we finished one run and we go up one and yeah. Move north. And I think that's it. A bracket close expected here. What did I... Let's have a look at for loops, how they are made. Because obviously I did that wrong. What? That's definitely not how I expected to do for ranges. God, this is Python, isn't it? I forgot that part. Oh God. I can do this. For I in... So this is actually y, right? For I in get world size, I suppose. And then the same is true for x, right? Does that... make sense? I don't know. We'll see. No, apparently it does not. There isn't enough indentation here. Oh, right, right, right. This doesn't look right. Yeah, I was gonna say this is the wrong indentation. Damn it. Like, really, Python, this is terrible. Like, you have to do this all in indentations.
You see it here. You, right.
1, 2, 3, 4. 1, 2, 3, 4.
Yeah.
3 can't be iterated in a for loop. The for loop must be given a sequence to iterate over, for example, for iron. Right, so this isn't actually a proper for loop. This is a for each loop, essentially. Jesus. Right, we'll need to enclose this in a range gate world size. And I did this wrong. Why? I should be looking for. Oh yeah. I'm doing this wrong. I'm looking for y equals 1, not x equals 1. That's why it's doing it in the wrong order. I don't understand what I'm doing wrong here, so stop. This block here is x1, y0, right? This is x1, y1, and this is x1, y2. For iron range, oh, this is not going to start at 0, this is going to start at 1, I think. Or maybe not. Yeah, I don't see you ever doing the plant grass. Why? We can probably do a like a print debug thing. 50 of each, sure. And I think once we've moved sort of thing into the next part, we're gonna do a print here. And where is print? I think that's what I want. Okay, so how does this work? Print some string, okay. X position we'll call this. And you just get a variable passed in. Get posix. And that's x position y. So that makes that makes no sense. If x equals 1, You're supposed to plant a grass entity. Did I do something wrong in the if statement? I don't think so, but... Okay, it doesn't get put into brackets. Is that maybe what we need to do? Like this looks right to me. Like I don't see why that wouldn't work. And you're just doing bushes again. Let's actually print X instead of... I'm gonna do 2 print outs, right? We'll actually say this is the actual X position, right? Which comes from get pos X, right? Patch enough. Not gonna be long stream today. X loop, we'll call this. And just print X that we're coming in from this X, from this for loop. What? So we're doing X's first, right? X position is along the bottom, that's moving to the east. Alright, that's the inner loop. And then once we've run through that, we move north on the Y. But there's a definite disconnect here. Can we maybe... I'm wondering, can we do something like this? Just add more string to the same line? Something like that, to separate it out a little bit. So somehow this doesn't work as I expected it, but then I may as well just say, hey, if get position X equals to 1, do that planting. Also, this is a function call. Let's try that again. I think the print is really holding us up here. So let's try that again. Yeah, but that's also not in what I had in mind. That's really not what I had in mind. What I wanted is that row to be in grass. That's it. There we go, finally. Cool. Yes, I am a bad programmer, and this is why we're learning this in very simple terms. What do we have? We have no carrots. We have no carrots at all, which get unlocked here with 50 wood. but I don't really want to go just there just yet. Yeah, we definitely want to work on carrots, I think. Not too terrible, actually. It needs tilling of the soil as well. I forgot how much we need. Oh, we need, let's do the wood first, I think, or... yeah, let's do some carrots, I think. Which means we need to till the ground first. So stop. And what we'll do is we'll do the top row. So that's an elif, they call this here, right? Elif. So basically else if, now we get another condition, and we'll say here get pos y equals 2. So we're on the top row, right? Then get ground type. So we need to say basically if get ground type equals, and then we can look that up. Get ground type. All right, if it's not grounds.soil, that's exactly what we want, right? If it's not grounds dot soil, then till. Yep. And then once we've tilled, we plant entities dot carrot. Right. So let's go. Oh. Trying to use not equals on the function get ground type. This is a function object itself. Oh, right. Because I forgot to use this as a function. I keep forgetting that.
Take your time, boy.
Good. So it's not constantly tilling the ground either up there. It's only tilling it when it's needing to be tilled. Perfect. Did we actually, will we clear the farm here? And I feel almost like wanting to change this all around. So we'll say do always grass, but when we're on one of the other rows, you actually go and make bush and carrots. Let's try this.
Bush.
Yes, we're making bush. Yes, this is what I had in mind. That's better. Okay, good. And then, let's see what our next unlocks are. So we need 30 wood and 20 carrots to expand our farm. Sure. So something like this. That's now a 4x4. Yeah. Perfect. Because we haven't actually got another crop type, so we're happy with this right now. Oh, increase the yield of grass, sure. Go for it. I guess we now look at the next unlocks. Oh, faster code and drones? Yeah, sure. We need a few more carrots, but okay, so growing carrots or planting carrots actually costs grass as well as wood. Okay, interesting. And yep, they're definitely going a little bit faster now. Good. What else? We could almost make a 6x6 farm, that'd be cool. Alright. Yeah. That makes it a... Nope, I missed something. 50 carrots and 100. We have that. Go do it. Thank you. Now, bigger farm. Good. Good. Now comes the point where we need to grow a bit more smart. We could water the plants, or we can deal in trees. Trees are weird, if I remember right. So, you know what? Let's go and leave the machinery running. But if it's 1, 2, we'll add another condition here. I hope this is how this works. If it's 1 or 3 or 2 and 4 for those carrots, or something like this. You can't do that. How do you do ors? Is it an operator? Oh, it's just called or. Oh, if it's 1 or 3, that's what it is. Let's see, we should see the next row being carrots, then bush again, then carrots again, and then finally up at the top is gonna be grass again. Right. That's just me now harvesting a whole bunch of this stuff right now. They've definitely increased this tree a lot since last time I looked at this. And there's a DLC coming out I'm looking really forward to. It's called The Miner Has Been Replaced, or was replaced. So, you know, doing the same thing but with mining instead of planting, which is actually more my length or my speed, I want to say. Okay, that's a lot of grass. Does that help us? I care not about hats at all. Hmm. Okay, well, let's have a look at trees, I think, because that's going to give us more wood.
Always need wood.
We always need wood. Right, so A, stop. Trees are a better way to get wood than bushes. They give 5 wood each. Like bushes, they can be planted on grass or soil. Trees like to have some space, and planting them right next to each other will slow down their growth. The growing time is doubled for each tree that is on a tile directly to the north, east, west, or south of it. So if you plant trees on every tile, they will 16 times longer to grow. And this is why we have the percent operator. And it returns the remainder of a division. So if we say we divide 5 by 2, just as a silly example, then your actual division result is 2 and the remainder is going to be 1. And that is what we're looking for, because we can look at that and say, hey, if the remainder is 0, right, then we are on an even numbered grid tile, and we can use that to say, hey, and actually I'm going to just copy this function here. I like that. Right? I'm going to literally just use that as our point to say, hey, where we are, is this an even or odd place? And if it is an even place, then we will plant something here, otherwise we shall not. And we will do this here for plant the bushes, right? Instead of making the bush, we will say, excuse me, if get pos x no, actually, stop. If is even, that's what I need to do. I need to pass my position in here. And if it is an even x, then we say plant entity bush, else we don't. I would also like to do this here, this tilling, because tilling does give you more resources. So we're going to say right here, before you plant the bush, check if the ground is a soil or if it's just grassland. If it's not soil, turn it into soil, and then plant the bush. But not the bush, but the tree. I think. And oh, I need to unlock functions first. What do you mean with that? Oh my god. 35 carats plus 40 carats is 75 carats. So I'm missing 5 fucking carats. Fuck you. But okay. Okay. What we will do, I will just cut this out for now. We can just express this actually here. If get position x mod 2 equals 0. And it's doing the trees in, with spaces between them. So you seem to be happy with that. Okay, cool. Yes, I guess. 2 seconds. Let me actually change this so we say 1 and 2. And then 3 and 4 is for carrots. And then what I'm going to do here, copy this, but see if it's not equal to 0, then let's see. I'm expecting to be basically having two rows of trees. Ah, shoot. Stop. Um, I think that's also wrong because I want this. Yeah, stop. We're not doing this. This is silly. This was me just trying to fill up more positions, but it's not going to work like that. Yeah, damn it. Wait, I can do my thing, can't we? Yes, we can. So let's clean this up a little bit. Def is even. If is even, get pos x, right? That is not a thing. Right, okay, so yeah, here's what we're doing. This is not right. It's this that we need copied. And if position is 2 and is if not, it's even, right? Is that gonna be a thing? No. We'll do it different. We'll do it, say, is odd. Oh god, yeah, if odd, and we'll say if it's not equal to 0, right? And then we'll say here, if it's an odd position, then do that planting. So far, so good. Yes, this is what I want to see, the sort of staggered thing. Good. And yeah, let's get that yield up. And would you believe it? It is actually coming up to my first break time. Sure. And in the meantime, we can just literally watch the little farmer drone do the farming and get us more resources. A lot more resources, I should say. But guys, and remember, if you like this sort of content and you want to see more of it, give me a like, a follow, a subscribe. I will be back in 3 to 5. And then we shall continue our journey into the farming. The farmer has been replaced by drones that are badly programmed by me. But with that, I shan't be long and see you all very soon. And with that, I am back. So, the drone has been busy. I noticed. I noticed that. Yes. Let's see what we can maybe unlock for ourselves to be better at things. I don't even. It's been a hot minute since I played this, and it was a much simpler back then. It's fine. Yeah. Okay, watering would be a thing, but that's also interesting code. I know that much. Let's see. Oh, more carrots? Sure. Let's go and make more carrots happen. Thank you. Yes, increase the grass yield, sure. And then I want to wait until we have 500 carrots. And then we can upgrade our execution speed. Zintengi, thank you so much for the follow. Welcome in. How are you doing? let's make this a bit bigger so we can see what's going on. Oh, there's my 500 carats. That was you. Now you need 1,000 carats for the next stage, but sure.
Yikes.
Yeah, it goes up in size very quickly. I love actually how you can see the program sort of running here in the lines. You can see exactly where it's at, even though it's very fast to follow, but that is cool though. You can literally follow that. I think it makes it easier for non-programmers to sort of visualize what the program is doing at each stage. I like that.
Understanding.
Hmm?
Better understanding.
Yeah, better helps with better understanding. Yeah, better carat yield. Sure. And then more tree yield, we'll do that as well. I'm quite happy with that. I don't know what those 500 things are. Is that something we need to unlock somehow? Possibly? A maze with treasure in the middle. Okay. Interesting. It's all fairly expensive, but basically to our next steps, I would really need to get pumpkins going. Now, pumpkins are interesting because they're not single tile entities. They like to be 2 by 2, 3 by 3. They can be quite big, actually.
Greedy, that's what they are.
They are very greedy indeed, but yay, hats. I'm just wanting to unlock, and then that is it done. Okay, let's wait until we have 2.5k wood, which should be happening fairly soon. Boom. Now, oh, your code triggered a warning. Oh, you didn't have the required item to plant entity card. Are you sure? Is this just a matter of us being a bit fast and not having enough? Excuse me, what's going on? Like, why? Carrots are broken. Okay, stop. And start again because that should clear the entire field and restart from scratch. So there we go. Carrots. Okay, good. Just getting worried there for a second. Let's go even faster. Why not? Okay, looking good. 12k, wow. Better carrot yield, but a 6k worth of wood. Be easier to do the trees first, because we're nearly there with that requirement. That drone is going something at some speed. Wow. Right, I'm gonna go and get the kettle quickly stuck on while, you know, more more grass and all that's happening.
You want coffee?
Yes. There we go. So we have enough grass now to upgrade that tree growing. Right, make them grow double as fast, or double the yield, I should say. Good. And then I think we shall look into water. So what I'd like to do, we're going to stop it and say yes, water. So plants grow faster when they're watered. The ground has a water level ranging from 0 to 1. The function get water returns the water level of the ground it is over. The growth speed of a plant scales linearly from 1x speed at water level 0 to 5x speed at water level 1. The ground dries up over time. On average, it loses 1% of its current water per second, but there's some random variance to this. Maintaining a high water level will consume much more water than in maintaining a low water level. And you can use water on your plants. 1 tank of water is automatically added to your inventory every 10 seconds. Upgrading unlocks watering will double the amount of water you get every 10 seconds. A tank holds 0.25 water. Call use items water over any ground to water the ground. Okay. I think I want to go and change this around a little bit and start making some functions for things. Um, okay, so do tree. Okay. And basically what we're saying I'm trying to think here if I can do this thing here where we say if it's even on one line planted there, if it's odd on the other line planted on the alternate instead. I feel like there's a programmatic way of doing this nicer. So basically this is what the function should be doing. Basically make sure it's tilled and then plant the tree. I think we can do an and here if it's an even. Thank you. And get pos y equals 1. Still not exactly how I would have imagined this. but that basically takes care of this entire block. Oh, dev to carrot. That just like this. I really wish there was a way of doing this nicely. That should do. And then so check if you can harvest and harvest. In that case, then you basically run these functions. Do tree checks for all position and places the trees accordingly. The same for the carrots. The grass then is a sort of fallback. Oh. Def do grass fallback. That's basically in any case where we don't have anything specific to noticing I had a mistake there, but that's fine. If get position is 0 or get world size, plant entities grass. Do grass fallback. Don't need semicolons and then move. You can move this way or you can move that way, but you got to move. So first off, is this still running? Oh god. Somehow it doesn't seem to be... Did I broke something. There we go. Is the game still running? Yes, game is fine, but I have errors. Oh. Get pauses function. Same here. That first row seems weird. But I think it's okay, like it's still doing the things I was expecting it to do. Okay, cool. Now watering. So this is a new function that we're making for that. Def do wet stuff, right?
Do wet stuff.
Yeah, we like to do wet stuff, do we not? I think we do. Get water. And we're saying if get water is less than. Let's just start with a fairly low value. If water is less than 0.2, we use items dot water, right? I feel like this may work. And then I just need to figure out when to do the wet stuff. Actually, right there, why not do wet stuff? Let's go. Okay, you can see the water being applied, but it's drying out fairly quickly, so and you can see the water level in there, that's cool. So it seems to apply. It doesn't actually say how much it applies per water usage. But I feel like we can go a bit higher with this. So let's say if it's under 0.5 maybe, and then water. Okay, we don't have enough water right now. That's why we're getting a warning there. So 0.2 seems to be better. Yes, 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 more water. That's going up a bit faster there, good. Okay, we need to go and run the program more and see how it goes. Good. We definitely need to go and work on pumpkins in the near future. Which also means we're gonna have to reevaluate how we're planting. And actually, why not? Basically, what I would like to do here is put carrots on the blocks between the trees, on the tiles between the trees. I think that'd be useful. So we actually say else. something like this. Carrot. And then same thing again, essentially here. Then that means we don't have the do carrot thing anymore. Right, because that's not happening in here, and then we can do pumpkins up here. So let's go and unlock them quickly. Right, and we could try for a 3x3, but I don't know if that's going to be useful because then that makes me not as much grass. So we'll try 2x2 maybe first, right? Patch enough. So when a pumpkin dies, it leaves behind a dead pumpkin that won't drop anything when harvested. Planting a new plant in its place automatically removes the dead pumpkin, so there's no need to harvest it. Can harvest always returns false on dead pumpkins. Right, okay, that's fair. Def to pumpkins. Pumpkins. And then basically saying if get position y equals uh, 3, right? Or equals 4. Um, do pumpkins. Making sure we are tilled. Right. And then if we are tilled, I think we just plant. Entities dot pumpkin. Let's try it out, shall we? I broke something. I broke something badly. Do tree. Well, okay. Oh God. I can type, honestly. Right. Basically looking at the wrong conditions here. Elif is even. Let's try that again. Yes. Or grass down there. Tree carrot, perfect, 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 yes! Haha! And you didn't do the pumpkin thing. Oh yeah, that's because I didn't actually tell it to do pumpkins, right? We didn't ever make that call. That would make sense. Dead pumpkin, fuck's sake. Well, at least we got one big one. Okay, nice. Two big ones. Still some dead ones. Not a single big one in this case. Jeez. But we are getting indeed pumpkins. That's something. Need a lot more wood for that. A lot more pumpkins. My God. Yeah, let's increase the carrot yield. Why not? Cool. Yeah, no, we're doing it. We're doing it. Slowly but surely we're doing it. Good. What else can I do is the question. Oh, fertilizer. Oh, God. That's a whole nother thing as well. Cacti? Wow. Use companion planting to increase the yield. Okay. So there's basically plants that have a companion that makes them grow better, from what I'm understanding here. Cool. We can use other files. I think that's going to be interesting in future to keep it a bit separate. I like that. So let's go and do that. And then we'll make a new file. Can we name this somehow? Planting. Okay, what I'm thinking is, or hoping to do, is grab all these. So, take all these. Plunk them in there. Import planting. And then, oh God, what was it again? Import. And then you just refer to that. So I say planting dot do tree, right? We'll do wet stuff in there as well. And see if it still runs. Oh God. Oh well, yeah, that's sensical because those functions are living in the main thing, and they shouldn't. We can just put them out here. Something like this maybe. And there we go. It's doing the thing. Good. Oh, that's deleting. That's not what I want. I want to just close it, I guess. Oh, okay. Right. Let's go a little bit further. What can we do? I can't do any of that. I'm really not doing well here at the moment. Lists. Huh. Dictionaries. Okay. Wow. I'm not sure entirely at the moment where to go with this. Can do fertilizer. Sort of straightforward. So stop. Um, okay. At some point, waiting for the plants to grow is just not efficient enough anymore. Similar to water, you will automatically receive one fertilizer every 10 seconds, doubling with each upgrade. Fertilizer can make plants grow instantly. Use item reduces the remaining growing time of the plant under the drone by 2 seconds. This has some side effects. Plants grown with fertilizer will be infected. When a plant is infected, half of its yield is turned into item weird substance when it's harvested. Weird substance can also be used on plant, which has the effect of toggling the infected status of the plant and all adjacent plants. So if you call use items weird substance on an infected plant, it will cure it, but if you use it on a healthy plant, it will infect it. But if you use it on an infected plant that has healthy neighbors, it will cure the plant but infect the neighbors and vice versa. Like, what in the... Wow. So you like need to double check the fertilizer. Um, fertilizer is what we're doing here, I guess. If to get ground type. No, God, how do you the fertilizer? That's not helping. That's just how to use it. That's not what I need. Mm. I don't think we can actually see the state of that, but that makes no sense. Get ground type. Yeah, what ground types are we gonna find though? Like, let me see. Built-in functions. Get ground type. Senses, yes, but mm-hmm. Hey, Messy Bex, how you doing? Good morning to you. Okay, so I figure we can't maybe do this, but we can check how many fertilizer we have. Items, the fertilize. Um, are you? What have I missed? It's not Thursday, is it?
No.
No, it is not Thursday, so it's not Dinkum Day or Update Day. But no, I'm glad you enjoyed excited. It's a good thing. If we have less than say 10 fertilizer, actually more than. I'm sorry. I'm sorry. Did you think this was Thursday? No, unfortunately, it's only Wednesday. I'm sorry. I feel bad now a little bit. How do you? Well, yeah, I do actually. I know what that feels like. Looking forward to something, you think it's the day, and it's not. I'm sorry. uh, um, I forgot how to fertilize. I mean, I know how to fertilize here in real life, but I don't think I can show that on stream. I might get issues. I might get banned and what have you. Yeah, use item.
Get banned.
Yes, quite possibly. I'm sorry. Don't go. uh, and then I guess we just say here do wet stuff and then we do fertilizer. Excuse me, why you're not seeing that? I'm just making sure I've wrote that right, but yeah, I did. And there's an error because you can't do this selection. You can't do semicolons. This is not a C-like language. But basically what I'm saying here is only use fertilizer if we have more than 10 of them up here. Then I also need to check. We met the biggest celebrity last night, Vonnie, in a chat on Tube last night. Oh, nice. I'm sure I'm missing something. Vonnie is going to be back. All right, nice, nice. She's not there at the moment, but she's got to be back in a minute with the dog. Yeah. I did this wrong. Uh, is it get items? Oh God. There's a thing you can do. Is it get entity type? No. Num items. That's what I was wanting. Ah, yes. If num items of items dot first fertilizer is less than 10, then you use such an item. And then, oh God, yeah, I forgot about that weird substance thing. Shit. Nice. Because I need to basically do a check here. if senses get entity type entities dot um where is just leave me alone. I'm working on it. Shush. How do you know though it's infected? That's what I'm wondering right now. Um, that's the ground. That's not. Um, items. No. Weird substance. Because that's what I need to detect. I need to detect whether our plant is infected by weird substance. And if so, use items dot weird substance. That's all I can think of at the moment. So let's nope. I hit execute on the wrong thing, but yeah. Oh, we have big pumpkins appearing. Okay, slowly but surely. Okay, looking good so far. And we're just not getting enough fertilizer at the moment, but
Okay.
yeah, slowly but surely it's going to build up, I hope. Oh God. I know. Uh, 2 seconds. I'm thinking about another game that we could try. If I can remember the name. Oh God, this is annoying me right now. If I look up Zachtronic games, then you will tell me the games, and I will find the right one. Where is it? Wow. Shenzhen IO. Yes, that's the one. Aha. So, are we still good here in Streamland? I think so.
Yeah.
Yes, because I'm sort of getting stuck here, and we're just waiting around. So I will install something else quickly. It's only 400 megs. It's basically got to be installed by the time I
Right.
yeah, come out of here and all that. But yeah, this is basically how the farmer was replaced works. You'd program this drone to get resources up here in the corner. Then these resources you use to upgrade your tech tree, get more functions, more trees, more plants, and all that, and just keep doing this thing until it's complete, so to speak. But yes, fun. Let's jump into something similar, but yet different. If it will, yes, it does. Good, 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 good. Let me go and change a few things on the because really that's what we're doing here. We're replacing, we're playing around, and this is Gen IO. There we go, done. Hey, everything creative, how are you doing? Yes, a long time no see. And let me go and change on the YouTube as well, because I did forget that. Because we're really doing all sorts of different things, so let me go and be that open in the title. So this is Shenzhen IO, or Shenzhen IO, and let me go and see if I can patch enough. Stop, just stop.
You've just been creeper. There you are.
I want to actually restart if that is a thing. Or maybe no, this is the thing I did. I didn't want all these done yet. Can I somehow please tell me? No. Okay. That is not what I was wanting to do. I really wanted a restart on this. There must be a way. No? No. That sucks. I was hoping I could just do a restart on this somehow. Okay, let's just start. You basically take on a job in China, in Shenzhen, and you make different things. So let me make a new design. We're not going to look at the design I made previously, but you can see here in the white bar that I was basically right in the cost, power usage, and lines of code for this. So let's have a look at the design and what we need to build. It's essentially sort of a low-level programming that we're going to do here. Uh, yeah, it's always meetings. Meetings always suck. Gotta admit. Yes. So basically, that's one part. We also want data sheets. I guess we'll open this in Firefox. And this comes literally with the game. Like you can just print these out if you needed to. And it's literally, how would I say, it's instructions for how to play the game, but more importantly, it actually tells you how um, these different ICs and all that work. Okay. Oh, yeah. Um, so like more importantly, we can see like how this assembly code is written in one thing. We see the registers we have access to. then moreover, if you can go further down, you have all these different microcontrollers and what have you not. And they have certain registers, they have states, they have, you know, certain expectations, and this is all explained here in the docs. But let's just go into our fake security camera that we're making, right? And to basically have this verified, we have down here a waveform that we need to replicate. So right now, if I go and just advance, we're moving 0 into P0, that's a register. We sleep for 6, then we move 100 into P0 and sleep for 6. So basically we turn on and off the active output for 6 ticks. 1, 2, 3, 4, 5, 6, and then you have 6 more for 6 are off and 6 are on. That's basically what we're seeing here. Now the network output hasn't got anything yet, so let's, why not? Right, there we go. Hopefully that worked. So we have 0 connected here. So we have 4 ticks off. So we move 0 into P0. We sleep for 4. Yeah, exactly. First come, first serve. Then move 100, so basically the maximum value into P0. Sleep for, what's that, 2 ticks. Move 0 into P0, sleep 1. Move 100 into P0, sleep 1. Right, that brings us here, which should then roll around back to move 0 and the 4 ticks there. So let's simulate. And that's exactly the output that we're getting here. So just as an example to maybe show what happens if we did this wrong, let's just change this 1 sleep for the 2 ticks here into 1 and simulate, and then now you see the red line actually sort of really diverging from our expected waveform. Right? So we need to go and do like so, and then we see the waveform now following the expected pattern and straightforward. Nice. We can make that a bit faster. And that is us verified. Sweet. I think my other solution looks exactly the same by the looks of it. Yeah, it's exactly the same. But cool. Then we have another job here. And let's just look at a new design. So control in is a simple input connected to factory equipment. Control out is a simple output connected to other factory equipment. The signal from control in should be multiplied by 2 and copied to control out. Seems straightforward enough. So we will hook you into P0 and you into P1. And so the X inputs and outputs, they are actually for analog inputs. So they take on different values, not digital values, basically, is what I'm getting at. But we don't actually have anything that interacts on that. I think something like this would, yeah, it doesn't matter. Yes, it is. It is indeed. And so we have verification. We have, this is actually easy. I need a register, I think, to just dump things in. So this is what we're working with. Oh yeah, we have ACC, the accumulator, that we can use. And basically I would move P0 into the accumulator, mul by 2, and move the accumulator, words are hard, into P1. Nope. Yeah. Stop. We need to have at least one sleep one somewhere in code. And that's it. Fairly straightforward, this one. Right? If you think about it, we're literally just taking the value that comes in from P0, we're storing it somewhere, and the accumulator is a funny thing, because what it does is whenever you do any math operation on any register, the result will end up in the accumulator. So what I'm doing in this case is we're just pulling our number into the accumulator, multiply whatever is in there by 2, and then take that accumulator and just push it out to P1. That's literally all we need to do here. But that's cool. And I believe my other approach is exactly the same. Yeah. I haven't learned anything new from here. Then we have a pulse generator. Apparently done in 3 lines. I don't want to look at that design yet because I feel like I have stole this from the internet anyways guys, if this is my break time again, and so for those that are new to my channel, I take a break every hour on the hour. And with that, I will be back in 3 to 5. Remember, if you like this sort of content and you want to see more of it, give me a like, a follow, a subscribe. It's always well appreciated. And after the break, we will just dive a bit more maybe into Shenzhen IO, and then I don't know yet, right? We're just playing around today. I'm just having some fun. I'm still recovering from this nasty cold, so why not? With that, I shan't be long. See you all very soon. And with that, I am back. So we are now making a pulse generator in this, apparently in 3 lines only, but let's see what the actual... Okay, so basically what we're doing here, when the button is on, we pulse for a single second. There is somewhere they have in here a command to make it easier to do these pulses. No. Sector map. Okay, not in here. I feel like there was some hint in the data sheets. They're just normal register, knob jumps. This is one way of doing it, and there's a better way. Come on. Jump and oh. This is bugging me. Because there's a mention somewhere. Okay, let's just have a quick look how I did it in here, and just the gen, that's the thing I was looking for. Generate a pulse basically. So back, go into our, so we have our verification here. Let me, this is probably going to be okay on a small, oh, this is the wrong controller. It's the MC4000 that we need, and hook in like this. Then I need to just do a compare. Let's have a look at TEQ. Okay, so R is a register and I is an immediate. So we can basically say test some register against another register, or some immediate value against another immediate value. Cool. Thanks, by the way, Vonnie. I don't know if I said it, but
No, you didn't. That's good.
yeah. Okay, so if that is equal to 100, basically, right? P0 100 plus, meaning that is the thing that we're going to do when that condition is true. Gen P1 on P1 for 1 second and 1 off. Think that's literally all we need to do, and then minus is sleep 1. Maybe. Yeah. Well, look at that. Okay. Now, if we didn't have this gen thing, we would need to basically go and say, why am I not seeing that? Hello, computer? Oh, there we go. I am so sorry that I've actually missed 3 people there. Hey, Rogue Ferula, Control F Pulse, Is that what I'm looking for? Is that what it's called? They're talking about EMP weapons, and that's the only pulse they have in there. But that's the thing, I know that there was this gen command. Yeah, no, it's fine. And hello, Westterm and Mr. Teds. Hello to all of yous. I'm learning this game. I have no idea. You're finding me gen anywhere, but so I don't understand how you are supposed to know that this command exists. The only reason I knew about it, if I'm being honest, is because I had looked up solutions to this before, like looking at my own solution. I'm like, I'm sure this could be done better. And this is where I had found this gen thing. But how did people find it? That's my question now. How did people find out about this bit if it's not mentioned in the documentation? Because normally you would write move one, oh god, move P0, no, P1 100, sleep 1, move P0 0. Oh yeah, wrong way round. Into P1 and 0 into P1 and another sleep 1. Not necessarily, because we could just say do sleep 1 like this. That's another way of writing it, but it's obviously longer, and I don't necessarily like this. If we can just say, hey, gen P111. And I think if you do this, then you have the off to be 2 seconds, 2 ticks long. Yeah. So if we reset that and maybe make it the other way around, so you can just see the difference there. It stays on for 2, stays off for 2. I'm not entirely sure what the 1 does at the end there, but this is how we need it. I know that much. Or not. Oh, wait, because... Yes. Because I basically say... Here, sleep 1, right? Yeah, it doesn't tell us, so I don't know. But yeah, with the pronunciation, I try, but I see so many weird names sometimes in chat. You know, lead speak is a really hard one for me to just get right, but I try. I'm very trying, my wife likes to say.
You are.
See? Now we have the next one, which is light up signs. Again, I don't want to look really at a solution that's already been made by myself in the past. Okay, click 0 and click 1 are simple outputs connected to display segments corresponding to a clicking animation. Drink 0, drink 1, and drink 2 are simple outputs connected to display segments corresponding to drinking animation. Control the display segments with fixed, repeating signals as indicated in the verification tab. Holy schnitzel. What are you? LC70G. Let's... LC... All right. 70G04, I think it was, yeah. It's an inverter. And that's the output table. How am I reading this? So if both inputs are 0, you make it 1. It's an XOR gate, right? No, it's not. No, it's not. So whatever comes in from A is inverted. That is what this inverter is doing. I don't even think it has a B input, if I'm being honest. Right. This is what we're seeing here, yeah. If you read properly, Sebastian, you could input, output, so it's literally, you're reading A and you're inverting it. That is actually cool. We can use that. I can use that. So let me grab one of yous. And essentially, whatever click zero's output is, click 1 is the opposite. Okay. And then I imagine we can maybe use you and go like this. And I almost feel like just gen 1 1. Like gen p1 1 1 sleep 1. Damn it. It's starting out the wrong way, I think. Mr. Ted, thank you so much for the sub on YouTube. What if we... Uh, 2 seconds, let me move you over 1 so I can get you in here and this maybe. Nope. That's why. I think we don't need to do a sleep because Jen has that built in, I believe. Let's that's it. Okay, so that's us done the first two. And it always looks the same, so when drink 0 goes low, we... This is right. We're gonna need... What's the difference here? So you're only dealing in X outputs, so that's not what we need. We need something that does this. Damn it. We need to move you over 1. Almost feel like saying we're taking output from there and make it... No, wrong. Maybe I need this guy actually. And running out of space, of course. Damn it. Let me see if we can move you something like this, maybe. Maybe that works, I don't know. Trying to get just a bit more space here. for my chips. There we go. So this is what I'm trying to do here, right? Is that what you mean with leaving a little tail? Something like this. Cool, 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 cool. I don't see enough P outputs though on this module. This is tab. You can just hold tab. I guess we could use an X input to pass the information on and then have you go in here and you go in here. Yeah, no problem. First off, let's simulate that this still works. Okay. I'm curious, can we just take you away and see how it behaves? Ah, okay, okay, we need that tail sticking out for the inverter to work. Okay. Basically we said 2, 4, 6, and 4. So move 100 into P0. P0, not PO. Sleep for 6. Move 0 into P0. Sleep for 4. And I think that's actually it. Right, cool, cool, cool. What I would also then like to do is move that same value into x1 and move 0 into x1, right? Because then we can do a comparison here and say, hey, if we are seeing that 100 value, we can then trigger these pulses. Right. x1, 100. Right. Oh, wait, it's x0, sorry. I do like that it tells you which pins are connected and which are not connected. That's actually really cool. So if we see 100 here as a value, I want you to move 100 into P0. Right, I'll string 1, yeah. P0. Sleep 1. Move 0. Oops. Move 0 into P0, but also move 100 into P1. Keep forgetting this. Sleep 2. Move 100 to P0. Move 0 into P1. Sleep 1 and don't feed the trolls. Welcome in. Yo, how you doing? Move 0 to P0. Move 100 into P1. Yeah. Sleep 2. then you are, yeah, I think this is it. I think this is literally the thing. Oh, from pop to CachyOS. Yeah, that's exactly what I'm running. I'm running actually on the 7.0 kernel, and it was scary over the weekend when that came up, but it's all working fine. And I went wrong somewhere. And then I guess if we're not doing anything, just sleep. Part not sleeping, blocked on read. Hmm. Again, SLX sleep until receive data packet. Ah, right. Let's go and look at SLX. Um, the second microcontroller shows the current state of the light in its ACC register. It waits for an Xbox value from the first microcontroller. Using SLX. Right, we do SLX first, and then we do the comparison. Right. Yep. And it's not down here. It's literally one of the first instructions that we're doing here, where I'm going to say whoop, SLX X0, because that's the one that we're waiting on. And you're doing it wrong. And reset. Step through it, right? Move 100 into P0. Um, and move 100 into X0, right? But there was no value 100. What? Okay, you're writing 100. Is that even right? I'm doing this on the wrong. I'm doing this on the wrong condition here. We need to do this when x actually drops off to 0, meaning this is here. That was me. Whoops. And almost. Okay, reset. I move 0 to P1. Sleep 1. And yeah, move 0 into P0. That's what I did wrong there. I forgot to do that. Yep. Woo! Apparently I've used less power than the average. I've made the production cost a bit higher. Yep. That's definitely a W. Definitely used less power than we did before, and also less lines of code. Interesting. Let me look at the other solution that I had copied from somewhere, I'm sure. Hmm, interesting. Yeah, this we could have just done with a gen 1-1. But I think in total, I like my solution, my new solution actually more. Because we're sort of really making this part super simple. Like, just looking at the verification, it's literally always the opposite of what the other input is, or output. So that's why I came up, or wanted to do some sort of inversion. And just looking at this, it seems to me, or it seemed to me that every time we are actually low on the drink zero, that's when these pulses come in, so that's why I'm doing this combination. And it works, so, you know, I can't exactly complain. So, what's next? Bring out the Baron. Let's have a look. We've done this in about 20 lines. Okay. Okay, point and foul are simple inputs connected to buttons. Display is an Xbox display output corresponding to a numeric LCD screen. The counter should keep track of a count, starting at 0, and ensure that the display is always showing the current value. Okay, when point is pushed, the count should be incremented by 1. When foul is pushed, the count should be decremented by 2, but not below 0. Okay. Almost feels like we want to be using one of these guys. Do like this. P1, P0, the P0, P1, yeah. And you just take some sort of X input from what I'm seeing here, right? So what's the verification look like? Wow, okay. Actually, realistically, I don't need to care too much about the evaluation in this case. What we need to do is we need to just listen for the inputs. Right, what are these modules? 100p14. Random access memory. So I can use this. Write to memory. Write 0 to x3 and move x0 to x2. I trying to understand this one at the moment, even if it's helping us as a question. Read the data back. No, that's not what we need. We would. Maybe this is actually going a little bit far. Maybe we just need to store the. We have a data register we could use instead of the accumulator. So I imagine what we're going to do is move 0 into that. Like, we're going to reset our program from that stage, and then nah, you can't do that. You really can't do that. I think we're just going to look for inputs. Teak P0 100. I think I have a far easier solution in my mind. All we need to do, move that, or even the accumulator, move that into x0. And all we're doing is just work with the accumulator. So when we push that button, we basically say add 1 to the accumulator. Right. P1 is 100, you sub 2. I think there's a less than. Test instruction greater than, less than. Yes. TLT. So if is less than 0, move 0 into accumulator. And then move the accumulator into x0. I think that's literally all we need to do here, and then do a sleep 1. Okay, so something went terribly wrong. Yes. Reset. I didn't step through this properly. Right. Perfect. Keep going. Then you're now seeing 100. You subtract 2. Right. Accumulator is at -2, which now you should correct and move that value back in. Cool. So it's not letting us go negative, which is good. Right. Advance to this step. Now P0 is 100. And I want you to add 1, which you did. Why? P1 should not be 100. Huh? Come on. Yeah, I don't know if I agree to that, because we should be reading the full button in any case, whether the first button has been pushed or not. Right? I mean, this one clear. That's me. I can see that. Oh, I think that's what it was, right? I think that's what you were getting at as well. So let's advance and step through this. So indeed, we add 1. Right. Accumulator holds 1 as a data, and if I step into that now, we send 1. Okay. Two, 3. I think we're good. Yeah, you were right. Missing qualifier, but I was thinking on the wrong line. But there we go. Yes, that's a W. That's a big fat W. I would be curious to see what I did there in 20 lines. with all that much extra power. Like, why has this solution been suggested? Because I will say this, like, the solutions that you're seeing further on, they are literally from the internet, where I'm like, I don't know how to do this. I want to understand it. And the more I look at it, this is not as optimal as what we did. Because we're comparing here our input. Okay, basically checking if the input is 0, move 0 into accumulator. If it's not, add 1. If the accumulator is 1, move 1 into x1. This is silly. Why not just push x1 straight, or the accumulator straight into x1? Right. Oh, because you only want values of 0 and 1, you don't. Right. If it's less than 0, move 0 into accumulator, move the accumulator into x1. This is still essentially the same, but I feel it's a bit more complex than it needs to be if I look at this solution. I mean, fair, right? This is all about learning anyways. A rubbish audio thing. Right? Okay, cool. So it's not just me. A rubbish audio thing. Let's see what the verification looks like. Audio in is a simple input connected to an audio source. Audio out goes to a receiver. Maximize is a simple input connected to a switch. And a signal from audio in should be copied to audio out, applying the harmonic maximization algorithm when the maximize switch is on. Look in the supplemental data section of the manual to find an advertisement featuring the harmonic maximization algorithm. Come on. Basically, this is the formula. Audio out is audio in minus 50 times 4 plus 50. And why don't we just copy this? Like we can easily transfer that into actual code. So audio in is, it's not an X input, it's a normal P input, okay?
No, nothing.
I wonder. I wonder why. I wonder how. What's the DX300? What is that thing? Digital I/O expander. This unique and useful part can read or write up to 3 on-off signals at once over a simple I/O X bus.
Yeah.
It is sure to find its ideal application in answering many of your control and signal processing needs. Contact us to request samples. This is actually what I want, I think. Where we just take an X input and turn it into a P. It's little Indian from what I'm seeing here. So the first value essentially represents the last value in that table from what I'm seeing here. I feel like I want to use one of these guys. No, this is not actually helping me. This is not. Uh, I think they are just literal logic gates. Eh, I would consider myself still a novice. I don't make money with this. I have never learned programming. I've never learned anything like that. I'm a hobbyist. I watch many YouTube videos. I look into documentation and things like that. But other than that, no. How? So you output things to X3. Yeah, I don't think I understand this at the moment. But I don't think I even need this. I feel like I'm overcomplicating things. So we need an audio out, right? That much is clear, and we need maybe I will grab one of these simple guys here. Ah. I, I can't even disagree. I honestly I can't even disagree. And even considering the fact that, my last couple of programming sessions, they were all done with the explicit wish and desire to not use any AI. So anything we did was looked up in documentation, in API docs, whatever, whatever I could find to read about the thing. That's what we actually did use. So, and one thinking here, I'm just gonna do like so, and this is our audio in, right? What we're gonna say is if P0 is 100, move 1 into X0, sorry, X1. So plus, if it is not, move 0 into X1, and then sleep 1. Right, then we are going to check actually, check the input of X1, so that's SLX X0, take X0 to, if it's 1, no, actually, let's compare to 0 first and say that we move P0 into P1, right? When that happens, we literally just pass the sound straight through. And in case that is not the case, we move P0 into the accumulator. Excuse me, if I could type harmonic, here's the thing. Let me just go and grab this formula. For the love of. Why? So you won't let me just copy and hey, fine. So we need to do audio in -50 first. So sub 50. Right? And then mul4 at 50. That's all happened to the accumulator, and then move the accumulator into P1. And I think that may do it. Nah. I love it. We made it apparently really expensive and also more power hungry and more lines of code than usual. Why? Can we look at the other? Oh God. But interesting enough, it's exactly the same thing. Oh, thank you so much, Rogue Ferula. Thank you so much, honestly, for dropping in, for all your interaction. 5 a.m. Get to sleep, my goodness. But yeah, you know what? I am streaming every day between 8 a.m. and 2 p.m. UK time. So weekdays, I should say, Monday to Friday. The weekends are mine. But yeah. So interesting. You take a P2 input, you just we compare X to 100. It's essentially the same, just that I have somehow made this first part more complicated than it needed to be. Because we've added these extra lines here. But I had the right instinct there, I feel. Let me... Shall we try this? Can we recreate this, is the question. Need to do maybe like this, and... I feel like this should still work exactly the same. Oh, what do you mean part not sleeping? Yeah, that's all it was. So same solution, and now our production cost is right where it wants to be. Apparently, there's a cheaper solution. I don't know. We've made the power usage drop, which is nice, and we've got our lines of code down as well. Cool. I'm happy with that. Okay. Um, right. Let's have a look here. So have a look. So time is a simple input connected to a DT2415 clock providing the current time. Okay, sensor is a simple input connected to an infrared sensor. Alarm is a simple output to the silent alarm. Okay. When the current time equals the on time, the device should be armed. When the current time equals the off time, the device should be disarmed. Whenever the device is armed and the sensor reads at or above a value of 20, the alarm output should be active. Okay, so we have two timers here that we can use for like comparing values, I guess, right? So we'll put the on time over here, maybe. Maybe right there. Maybe even just like that, and then we'll put the off time down here. So this is our real time. Let me guess you're a P input. Something like that. Right. And then we can maybe do one of these guys. And boom. Uh, I would say we're gonna compare P1 to X1, right? If it's on time, then we're gonna say if P0 is larger than 20, x3 100, move 100 into x3. Else we're gonna say move 0 into x3, right? Just to sort of maybe have that clear. P1 x2. That's actually when we're doing that. Move 0 into x3. So this is simple sensor input. Oh god, we have a non-sleeping part. That's my fault. You don't sleep on a US schedule. You'll be back. I'll be back. So this is now where you should trigger, meaning you should do that comparison. I'm actually never doing a compare against P0. So yeah, no. No, I do here. Again, let's step through. Right, you're moving 100 into x3. I don't see it coming out of here though. Is this because we need to actually hook it up to the same line here? No. Hmm. Let me figure out again how to use that thing, what's it called, the DX300. It's a read and write. It's a simple I/O there, right? Oh, right. If I want to move 100 into P1, then I should send an XBus value of 010, I think. 010. Almost, but we're not resetting. Something like that. Also not correct. Why not? So you did it the first time and then so 93 is our current time. That's our on time as well. Right. Oh my goodness, would you believe it? It's my break time again. Which is probably a good opportunity to take a couple of minutes and look at this again once we come back and see what I did wrong. I feel like, I mean, this is working fine, right? Then the time drops down to some value, right? Why should you trigger? I don't understand this. Because we're clearly, like, our time is down here. We're not. It's like over here, this is where it should turn off, on again. No, where it should turn off. Wait. Not t equals p1 x2. It's less than, right? And where's my on time? That's x1. That needs to be a greater than or less than. Let's. Yeah, I think this needs to be a less than as well. No. I mean, what's actually, if we go and step in 84, I don't think I understand the on and off time quite right. So this should be on time. Right. That makes sense. Then you're dropping down here. This is where I'm getting confused. Right. If P1 is less than X2, don't do anything, like, and sleep. What is the sensor input right now? 23, so it should trigger because it's above 20. P1, X2. That's also wrong. No, it's not. P1 is, oh god, getting confused. Yeah, if it's less than the off time, right? It shouldn't. Yeah, definitely sending the wrong value there. Also, this should be a minus, and we should move 010 into x3. Yeah, not quite. Okay. After the break, we're gonna debug this properly. Guys, if you like this sort of content, give me a like, a follow, and subscribe. I will be back at 3 to 5, and then we shall try and debug this. messy thing. But with that, I shan't be long. And I am back. So, what are we doing? We were trying to debug this sugar mess. Oh, sorry, went wrong there. God. This on and off time thing is really confusing me a little bit. Um, I think it needs to be greater than. So where's our time coming in? On P1. So we'll do this greater than. And yes, less than off time. Right. You then check whether the sensor is over 20, and if so, move the alert value in. If not, just move 0 into it. Um, hmm. Not sure what I'm doing wrong here because their value goes from 90 to 0, 95 even, but hmm. Weird. Like, I'm not sure if I understand this right. So if our time currently is larger than the on time, is that even right? Equals the on time. What's the numerical values for DT 2415? Like what? DT 24. Yes, timekeeping. Okay. So you just return in numbers from between 0 and 95. That one's not connected. It's literally just the time index that we're getting out of here, of the bottom one, and that's it. We're not going to compare this to the Dallas chip, of course. That's different. Because the equal thing with the time, the reason I don't think it's an equal, because it says here when the current time equals the on time, but the time doesn't stand still. Time moves on, so it will either hit that point or be greater than that point in time, right? And what do you mean with armed and disarmed? Like we haven't. It's not like we have a specific state for that. I guess what we could do, we could store this armed state as a type of data in our register. Let me go and remove all of this and let's start from scratch. So we try to think. So if P1, that's our pin taking in the time, it's greater than X1, that's the on time, right? In that case, that equals, I'll move 1 into that, basically meaning we're on, right? Less than, so P1 is less than X2, move 0 into that. And then we just basically say if X that is 1, we now go and check the sensor. So T larger than P020. Then move 010 into X3. Yeah, I don't know how to deal with these two equalize, like the two if statements, like how to do this properly. Stupid question. Do we have something like a jump instruction? Yes, we do. We could also just do a nop. Ah. I think I want to do this in labels. So how does this work? Alarm is the label. Jump to alarm or not. And something like this. It's time to justify. Then we'll just do here a jump to start. It's time to justify. Let's also make a no alarm if I can. Not enough space for that.
You okay, buddy?
Move 000 into X3. I think this is all we need to do then. Oh, I haven't got a sleep in. Oh, that's fair enough. Didn't do that right. Because we're jumping to start there. And again, something's not sleeping. Let's try here. Almost, but not really. Interesting. So greater than don't work there. And still wrong. Wow. Wow. Yeah, I'm not even sure what I'm like how to wrap my head around this. My brain's starting to not brain anymore. Uh, P1, X1, that should be true now. We all got left behind. I mean, the alarm is now armed. And P0 is 35, so definitely larger than 20. Oh, less than. That's wrong. It's greater than. Jump to the alarm. Right. That's the alarm going off. Jump to alarm. And should turn it off again. Okay. Right, this is, what's the time here at the moment? Time is 1, which is less than 38. And this is where you're saying the alarm isn't armed. Yep. Jumps back to start. And that is wrong. That is wrong. So where's the X2 compare? Actually, I think, where's it? P1, X2. Well, if we just actually say is when it's equal, move that data, that 0 into data, and then compare it. Yeah, maybe we'll go through that way. So let's advance up to this point. So you should be armed and should now recognize an alarm. Jump to alarm, but the target value should be less, so you should turn this off again. Cool, so you're doing that. Next. And then you should alarm here. Okay. Sending 0. I think we're actually done. Oh, okay. Okay, yes. W, it's a big fat win here. So basically what I'm doing is we're waiting for certain times to pass. Once they have basically hit our counter, we just set that to either 0 or 1 to arm our alarm and then just evaluate the sensor condition, depending on whether the alarm is armed or not. Okay. I thought we had verified this. Go on. Oh, okay, no, we didn't verify because something went wrong back here. What happened? Let's just advance all the way through here. And I imagine it's somewhere here where it goes wrong. Okay. Time is 39, our current is 38. Okay, let's step into this. Stop. Stop. No, compare the data to 1. It should be 0, which means you should be doing a NOP. Right?
You need a drink.
You're comparing again.
Drink. No, drink. Drink. You shouldn't drink that.
Oh, seriously, where did you go wrong?
Here you go. Have a drink.
Okay, let's go and advance a bunch here. Okay, what's values right now?
Doesn't need to apply a patch.
Come on then. Come see me. Oh, hello, boy. Yes, I see you. I see you. And he's got big smiles. uh, uh, this was all fine. Somewhere back here it went terribly wrong. Uh, 2 seconds. Sorry guys, I'm gonna have to call it. Something came up. I will see you all tomorrow. And with that, I will see you all